and we observed that there is a lot of demand for speakers who actually can talk about space and how to manage the space. First of all, living in the space and managing the requirements for who will control and which agency of the government will control the things that happen in space. For example, there was an anti-ballistic test done by China and India recently, and how does it impact the GPS system and everything else. So we got great speakers today. I'm thankful to Michael Staab and Shawn Boike for coming on board and helping the section and helping the society. So looks like we have enough quorum. I want to just briefly talk about our section and to encourage you to volunteer. We actually, all of us who are supporting the activities in the AIAA section are volunteers. We don't get paid by AIAA. We do it because we enjoy. We are passionate about aerospace. At AIAA, our purpose is to ignite and celebrate aerospace ingenuity and collaboration. And it's important to our way of life. Our promise is to be a vital, lifelong link to the aerospace community and a champion of its achievement. So AIAA section is home to one of the largest number of aerospace companies in the world, with a highly dense population of aerospace professionals. Our section has large number of aerospace companies, including JPL, Boeing, SpaceX, Northrop Grumman, Lockheed Martin, and then name the company, they have either the office or a headquarters in the vicinity of our section. We have close to 10,000 community members in our contact with our community members. We have not just aerospace professionals, but we have people from arts and movies and other backgrounds. For example, our board member, Veronica, she's made recently creative masks which have AIAA logos. And if you want those logos, just contact us and we'll try and provide them to you. So we have all these creative people who are passionate, who are working on their own to help the society. And the COVID-19 has made all this work from home, and there are layoffs happening. Many of the companies are laying off, and we expect about 30% unemployment rate. That's what the news are saying. So with all this, I think it's more important that we are connected to each other through these weekly meetings, and probably a happy hour we have on Friday for people to come and join, learn about technical stuff, and also learn about each other's problems while we go through this COVID-19 lockdown. Although we hear May 15 as a liftoff date, but I think for the sake of our community members, we are not planning to have any meetings until we are 100% sure that there is no more case of coronavirus in the staff. So meanwhile, we're going to continue having these meetings. If you want to volunteer, if you want to speak on the events, or if you want to do any other activities to help the section, please contact Ken or contact me. We're happy to take your help. And also, AIAA is offering a 1-year free membership called eMember. Please take benefit of that. And I really want to encourage you to participate, help the society. Children are at home now. So if you can, that'll be great. And I appreciate that. And then briefly about today, today's entire session is being recorded. It will be put on YouTube as well as our own websites, AIAA-LALV.org. All the events are also on our website, AIAA-LALV.org. So if you need future organize events, just log onto the website and find out what events you like and what events your children would be interested in participating. We have great talks about YP and STEM talk coming up in next couple of weeks about also using new softwares and stuff like that. Can you go to the next chart? I think before we go through the entire stuff, I'm just going to introduce Michael. Michael is a very enthusiastic. He works at JPL, and he was very kind to agree to give a talk. He's also a chair of the San Gabriel section. Michael is a flight systems engineer for the NASA ISRO Synthetic Aperture Radar mission at the JPL, NASA JPL. He's avionics system domains lead for the mission, responsible for nominal and off-nominal behavior and the functions design, avionics systems verification and validation activities. As you can see from award, he's got a bunch of awards, and he's also doing PhD. Absolutely wonderful, smart guy from having a background from Navy and working for government and helping the society. We appreciate him coming down and providing his expertise to the section. Can you go to the Space Force chart? Next one. And Shawn actually spoke to our conference, but we realized that a lot of people actually want to hear about it. In fact, I also want to hear from what Shawn has to take and ask questions. And we didn't have enough time in the conference, so we requested him to give one more talk, because it's kind of a very important topic for the aerospace community to understand what's happening in the space, who's responsible, and how is America going to protect the assets of GPS and other satellites in the space, and who's organizing these things. So Shawn has created, lead, directed, managed, and consulted in various teams, and professionally worked in Fortune 100 companies, NASA, NSF, DoD, Boeing, GD. So he just worked for, he is absolutely a wonderful guy, having experience with all these industries, and he's we are blessed to have him to give a talk, maybe extended talk, so people can ask questions. In fact, me and my wife have questions for him. So we are grateful for Shawn. Ken? So what exactly do you have now? Do you have are you going to take the control over the event?
No.
And have?
No, you are the moderator. So now the next Michael is going to present.
Yeah, Michael. So now we have absolutely a distinguished speaker from JPL, Michael. I also am encouraging him to talk about the career in JPL, because many of our members want to actually work for all these companies, and maybe some of the experienced professionals also need jobs. So if you can talk briefly about opportunities, employment opportunities, and also how does it look like working in JPL? That'll be very, very nice. Michael?
Okay, thanks. Just give me 1 second here to share my screen. Share. Okay. And let me pause that for a sec. Okay. Let me see. Oh. Nope.
Michael, your video hasn't shown up, your face.
Yep, let me 1 second to pull that up. Start video.
Okay.
All right, everyone, can you see me? Can you hear me?
Yes.
Awesome, okay. Yes, thanks for the invite today. Today we will be talking about JPL's Pride and Joy right now, and something that is going to be launching here very, very soon to Mars. Mars 2020, despite all the stuff going on with COVID, this is considered, I think, one of 2 of NASA's top priorities right now. So Mars 2020, getting it off the pad. And then Crew Demo 2 with SpaceX, I guess this month now. So in like 26 days, something like that. So those are the 2 top priorities for NASA right now. So Mars 2020. This is our follow-on to the Curiosity mission from 2012. It is part of an ongoing scientific expedition of Mars to eventually bring samples back from the surface. We'll talk about there's an instrument on board this vehicle that can do that, although we do not have a funded mission for Mars sample return MSRs, as what we call it right now. We are definitely doing the studies, and because we're sending this mission with the instruments to potentially do a sample return mission, it definitely has got a lot of people very interested. So with that, I will start with a video of some of the integration activities we've been doing in the high bay over the last year. Okay, so that's just a little preview. Let's move on. That's just a little preview of the work we've been doing in JPL's high bay, what we call the Building 179, the SAF, the spacecraft assembly facility. So over the last year or so, we've been getting parts into the high bay, putting the thing together, and it is now at the Cape. Arrived, I think, sometime in January this year, and right before all the COVID stuff started. So. She's been down at the Kennedy Space Center. They're just finished, I think, the last sets of integration. They've got the fuel tanks filled for the descent stage and the crew stage, and they're going to begin the final stacking assembly before they ship it over to the United Launch Alliance facility to stack it on the Centaur and then get on the Atlas V. We have just a couple months to go, so everything's still going, hopefully well, so that we can get the thing off the pad. I will say that if you have any questions at any time, just put them in the Q&A box and I will field them on the fly. So some of the things we're going to talk about all the things we saw in the video, but you see things there like the full stack, we have the crew stage, the descent stage, the rover itself, the back shell, the heat shield, all those different things. So yeah, if you have any questions, just pop them up and I will I'll answer them on the fly. Okay, so coming in 2021, February, I think it's February 17th. I think that date is probably off. On-time arrival at Mars in Jezero Crater in the northern hemisphere of Mars. This site was chosen particularly because of its potential biological signatures that it may have there. Geologists from orbit determined that Jezero Crater is actually an ancient river delta. So there's a ancient river on Mars that flowed into this crater and created a river delta. And river deltas are very fertile places. You only have to go look in Egypt at the Nile Delta to see how fertile that area is. So when it comes to trying to find life, this is a very good place to look. So we are sending the Mars 2020, which is now the Perseverance rover, to Jezero Crater to do biosignature type of analysis and in situ operations to take not only to study the area geologically, but also to take core samples. That's one of the primary goals of this mission is to do core sampling in the Jezero Crater region. Okay, let's move on to the next one. So to give you a little overview of Mars exploration as it has occurred over the past 20-some years. We started a little bit further back here than 2003. We actually have to go back to 1997 to the Pathfinder and Sojourner mission. So Pathfinder was was the first time NASA had landed anything on Mars in over 20 years. So the last time was the Viking mission in 1976, I believe, for the 200 centennial of the United States. So we go a little bit further back than that, but the next missions we sent were the Mars Exploration Rover Spirit and Opportunity. I was a flight director for Opportunity, so I have a little special place in my heart for Mars exploration particularly. So we go to Spirit and Opportunity, and these were missions that were sent to follow the water. They were sent there to look for the geological evidence of past flowing water on the surface of Mars, and they were exceptionally good at that. Exceptionally good, and they lasted for almost 15 years. So great piece of hardware. We learned a lot about the geology of Mars. We learned a lot about its past climate and its ability to support life. We didn't have the right instruments to look for life, but we definitely know that Mars in its past was a very wet place, just like it is on Earth. And then so we go throughout the case. We have Phoenix Scout that went to the northern poles and found that, yes, indeed, there is water ice on Mars. It's just trapped in the poles, and it may be there when the poles sublimate, but we do know that there is water ice on Mars. And then we go to the Curiosity rover, which launched in 2011, arrived in 2012, and it took a chemistry lab suite with it and used it to study the chemical makeup of the rocks in Jezero Crater to look again for more evidence of past life, that the chemical was the right chemistry available on Mars for life to actually exist. And then just 2 years ago, we sent InSight. So InSight landed on Cyber Monday in 2018, and it was sent to look to see if Mars is still geologically active. Does Mars have Marsquakes? And in fact, yes, it does. We're still working on getting the MOLE, the heat probe, into the surface. I know that team is working very hard to try and get that down, because the other thing we want to take is Mars's temperature to see if it's still giving off the radioactive decay of materials in its core to keep the planet heated. Potentially, again, is Mars still geologically active? And then this year, pending, actually, this guy is not going anymore. So ESA decided earlier this year that they're having too many issues with the parachute. So ExoMars is delayed until the 2022 launch window, which will be July, August, September. It'll be about September, October of 2022. But for us, for NASA, we have the 2020 rover, which is what we're going to talk about today. This is a bio detection mission. So its primary mission is to look for signs of past life and to take core samples of that, potentially send those back to Earth. Let's see, we have a question here. Can you talk about how the Mars helicopter Ingenuity will be deployed on the ground? The helicopter is mounted on its side to the belly of the rover. Yeah, so there's a mechanism on the bottom of the rover that will tilt it down so it'll land on its legs. The rover will back up away from it, and then we'll send the commands to spin the rotors up, and then off it goes. Okay. So we know that Mars, there's plenty of evidence that water once flowed on Mars. We know this from the Spirit and Opportunity rovers at both sites that the MER rovers went to. So let's see, Opportunity was in Mariotti Plana, which is a plain, and then Gusev Crater is where Spirit went. And we know that on these two very different regions, we know that there was a lot of evidence of past water flowing on the surface. In Meridian and Planum, we know that Opportunity found evidence of neutral water, so water that is pH of 7, stuff that you could actually drink. So a great place for little microbes to potentially swim in is in Mars's ancient past. In Gusev, we know that this place was much more geologically active in its past. We have more evidence of these hot springs that were found by Spirit, and hot springs are a great place because you think of it as like this hot soup where you have all these organic reactions, organic chemistry reactions going on. So potentially a very good place for life to be forming. So we know that the planet was once wet and habitable, and that had all the basic building blocks for life. And those potentially do still exist on the surface because we found the geological evidence of them, and Curiosity has found the chemical evidence in the rocks that those actually existed. So the question a lot of Martian scientists ask today is, why does Mars look like it does today? Why does it not look like the once wet, fertile place when it was? And a lot of that probably has to do with the fact that sometime in Mars's ancient past, its core seized up. It either got too cool and that iron core just stopped spinning, so it seized up, and Mars lost its magnetic field, and then the solar wind comes by and blows all the atmosphere away, you lose pressure, and then all the water basically just evaporates and then just gets blown away by the solar wind. But we do know that Mars once in its ancient past was very wet. We knew that it had the climate to support life. So the answers that we want to ask, and this is what this 20+ year Mars campaign is about, is did Mars ever have life? So we know what Mars once had. We know that Mars once had what life needs. We have the evidence in the geological record. This next rover is meant to answer those burning questions. Did Mars ever have life? So Mars 2020 will look for signs of past life itself and prepare for eventual human exploration. So the goal with NASA is always to get astronauts to the surface. So we do carry some instruments that are technology demonstrators for technology we would need for astronaut missions. So a little bit of dual stuff. We have the capability to take a really interesting instrument called MOXIE, which we'll get to. That is it was an instrument sponsored by the Human Exploration and Operations Mission Director to NASA for developing technologies that we need for crewed missions on the surface. Okay. So Mars 2020 will look for rocks with the potential to teach us about the possibilities of life on Mars. What it's going to do is we're going to pick the best samples and store them on the surface for potential future use. So we have an instrument on board. It's called the sample caching system. It's a very complex robotic mechanism. It's actually 3 robots in one. And what it uses and what its function is it takes core samples in regions that the geologist tells they want to take a core sample. So we take a core sample, we transfer it to another robot internally inside the vehicle. We rotate it into a tube that we vacuum seal and then put into a storage device that stays on board. Eventually, we're going to drop these off somewhere on Mars. From the moment that the core sample is taken to when it is vacuum sealed, it never touches, it's not meant to touch anything else. So we try to keep it as sterile as possible because we have these planetary protection requirements that we have to abide by. And in this case, with Mars 2020, potentially Mars sample return, we have to talk about reverse planetary protection requirements. So rather than protecting Mars's climate or Mars's biosphere from our germs, we now have to protect Earth's biosphere from Martian germs, potentially. We're not saying that it's going to happen, but it is something we have to think about. So these core samples are the keys to teaching us about past life. Our rovers are very smart. We have very good instruments, but unfortunately, our instruments are just not good enough to replicate what we can do in a laboratory. So the best samples we could ever get from Mars are actually the ones that we can return. Martian meteorites actually tell us a lot about Mars's past because they're actual samples from Mars, and we can do the breadth of scientific investigation in our laboratories with them. So the key is to get the samples back to Mars, or to get the samples back to Earth. So what we need to do is we have to core these samples and get them back. So if we brought them back someday, we could find out what's really inside of them because our instruments on our rovers, like I said, are just not good enough to give us that detail. So we would bring them back and we would study them in detail in our laboratories. And particularly what we're looking for is we're looking for biosignatures. So these are objects, substances, or patterns that only life-based processes can create. So I'll give you some examples. When Mars 2020 is looking for biosignatures, we're looking for patterns in the rocks, such as the isotopes of the chemicals that only life could leave behind. It's like a fingerprint of life. And unlike any Mars rover before, 2020 has the tools to look for these fingerprints, map those signatures, understands formation and origin. With its instruments, 2020 will be able to image and study these Mars rocks in detail in its original pristine condition without breaking it down into its constituent elements or ingredients. So this preserves a lot of the contextual information that could be lost otherwise. It enables a greater variety of measurements, scales, and contexts, thus making it possible to look for a larger variety of biosignatures. So this is really one of the driving scientific requirements is to find these potential samples at different locations in Jezero Crater and make sure that they are potentially the best candidates to have biosignatures within them. We can use our instruments on board to look for that evidence to tell us whether that's a good sample, but the only way that we can really know if it potentially had a biosignature in it is if we brought it back to Earth. Moving forward. So what we have at JPL is we have a crew, we have a team of scientists that are part of it, that lead a working group that selects the landing sites. And I've worked on the Mars Exploration Rover with the scientist who has selected the landing sites for every Mars rover since 1997, which is actually pretty cool. All the landers and all the rovers. So when they get, so this team, they get a candidate list of potential sites that we want to go to. And we don't necessarily rule out sites we've been to before, but sites that we have gone to typically get rated a little bit less because they're places we haven't gone to. But this crater in particular, and this is Jezero Crater, this one in particular got the attention of the science community because, like I said, there was actually a graduate student. There's a graduate student who was looking at imagery here from, I believe this is from MRO, and looked at this image and used the instruments on the orbiter and from some of the other orbiters and determined that this was actually an ancient river delta. So this black line, this black oval here, this is what we call the landing ellipse. So for the EDL system, this is within this region, within, I believe it's 3 sigma, this is where the vehicle is going to land, somewhere within this area. Like I said, Jezero Crater is home to an ancient river delta. There, the rover can access rocks that are up to 3.6 billion years old, which is about as further as let me see if I can say this right. It's about as far back in the geological record as we can get. Mars formed roughly 4.6 billion years ago at the formation of the solar system. So these are about as far back as we can get to look at the rocks. So we're talking about the earliest type of geological processes that were going on Mars, as well as looking forward in history potentially at how life and other processes may have been churning to produce that life. So it's a very interesting region to go study. And I know that the scientists are very, very interested in going to this place. So I got a little animation here. So Jezero has rocks and minerals that could only form in water. We know this from orbital imagery and from our spectrometers on our orbiters, that this place does have the chemicals that can only form in water. So things like hematite and various other minerals that they can only form if you have the presence of flora and water. Some are commonly associated with life on Earth. So this makes it a great place to look for signs of habitability in past life. So you'll see here we're within our landing ellipse, and the center point is where we hope to hit. We're going to be a little bit further away from the delta because the delta is a little bit elevated, so it's not safe for us to land there. So we're going to land here, and we're going to do our commissioning for the first 90 days, and then that white path is how we're going to drive over to the river delta. So we're going to drive through the river delta, and then we're going to move up the slope. And when we go up the slope, we're actually going earlier in time, because if you start at the very bottom of the crater, that's the most ancient form of the rock. And then when the crater head exposes the ancient rock, and then as you go further up the slope, you're going earlier in time, not farther back. So the prime mission is slated to last for 1.5 Martian years, which is 3 Earth years, because Mars year is about 2 years. A Martian year is equivalent to about 2 Earth years. So we're going to land, and we're landing at this place called Midway. Midway being the fact that we go up the slope, and if we find stuff and we like it, then we potentially could drive back further deeper into the crater if we wanted to, or we keep going up the slope. But at the end of that 1.5 Martian years, all the samples we've taken, we are to deposit on the surface and leave them. Leave them potentially for a Mars sample return mission to go and retrieve them and then bring them back to Earth. So when I do a lot of these presentations, I get the first question I get from a lot of students kids are very perceptive. Mars 2020 looks a lot like MSL. And you'd be correct, yes. Mars 2020 does look a lot like MSL, because when we pitched the mission, we pitched it to Congress and said, we have this rover architecture. We've been developing it over the last 15 years. We understand these systems very well. So why don't we take a lot of the hardware that we already know works and just reuse it again? So it uses the same computers, it uses the same telecom system, it uses the same mobility system. It uses a lot of the original rover electronics, the flight system electronics, a lot of the flight system hardware. The chassis is the same, the mobility system, so the rocker bogie, this black thing here. And I should note that this is not a picture of Curiosity on Mars. Okay, this this is a picture from Earth that is superimposed on Mars, because we obviously can't take a picture like this of the rover from this perspective on Mars, because the only cameras we have on Mars are on the rover itself. That is another question kids like to ask quite a bit. But you'll notice that the rocker bogey system is very the same. These 4 cameras up here we call HAS cams. Those are inherited. The telecom system is the same. The reels are a little different. So we learned something about driving over sharp rocks on Mars with Curiosity, that paper thin titanium breaks very easily when you drive over it because it creates stress concentrations. So we upgraded the wheels and made them a little bit beefier this time, so we don't expect to have any of those wear issues on the wheels this time. Uses the same power source, has a radioisotope thermoelectric generator. The design of the mast is roughly the same. We have a different laser than last time, but the cameras are basically the same. They're a little bit upgraded. So as we pitch this, Mars 2020 is Curiosity 2.0. It is basically Curiosity with new instruments. That's the only difference. So this vehicle has a lot of cameras. There's actually 23 cameras in total. So the new one we talked about here is SuperCam. So this is our laser. We can actually fire this onto a rock, and we can burn away the oxidized material on the surface of the rock and actually look at the rock as it actually looked like before it was oxidized by the atmosphere. These mass cam Z's. So this is how we think of this like panoramic cameras. So we can take panoramic images of our vicinity. Nav cam, so this is what we use to drive. So we take these images and we create these 3D meshes of the surface with our ground processing tools. We can actually create a 3D image of the environment around us, and that's how we actually can drive safely over the surface. We have 4 rear HAS cams, 4 front HAS cams, and then very interesting instrument on here we call SHERLOC and Watson. So SHERLOC and Watson, that's a I believe a micro context camera. Actually, I think this is the microscope, and I think this is a spectrometer. But yeah, so we have a lot of cameras on the vehicle. This is how we're able to navigate properly. This is how there's a lot of science. You can learn a lot from a panoramic image about a site, because different elements give off different wavelengths of visible light, and we can use that information to kind of tell us the context of what is within that rock. So 9 engineer cameras, 7 science cameras, and we actually, very, very neat this time, we have 7 entry, descent, and landing cameras. So for the first time, we're actually going to record the EDL once the vehicle has detached from the back shell. So we can actually watch the sky crane happen, which is going to be really cool. I hope it works. I hope those cameras work, because it's going to be a really, really cool image. We have cameras that look up from the rover to the descent stage, so we can watch the pulley, that pulley action as it lowers it. We have cameras from the bottom of the descent stage looking towards the rover as the rover descends down, and we actually have cameras looking sideways, I believe, off of the system, and also cameras looking up towards the sky. So this is going to be really cool. It's going to tell us, it has an engineering purpose. It's meant to tell us, it's meant to be used as a visual of the EDL, how that sequence works, so we can use it to further refine and make our EDL systems better. But I would say it also has an outreach sort of context, because you show those images to people and they're going, it's going to blow their minds. Like, it's going to blow our minds. It's going to be incredible to look at. Okay, so the science instruments we have on board study objects large and small, near and far. So the SuperCam can fire a laser to check out rocks from a distance. The Mastcam Z form our pair of eyes, so like our rover eyes. This is what we call on MUR is what we call the PanCam, the panoramic cameras, or the mast. So the mast consists of the head here, and you think of it like a set of human eyes. That's how we're able to see. It examines rocks and soils with a camera. It has a zoom on it, so we can actually zoom in on rocks. Something that Spirit and Opportunity didn't have is we couldn't zoom with our camera. So we had to make sure that the images we were taking were within the focal point, within the focal plane, so we could actually resolve those images and they weren't blurry. Let's see here. Do I have any notes I put here? SuperCam can see across great distances, measure targets not reachable by our tools. Basically, very, very, very sophisticated cameras for taking images on Mars, for driving on Mars, and for shooting lasers on Mars. We did a funny sort of insight for those that have worked on the team. we actually have a flight rule that says that we are not allowed to fire the laser while the helicopter is flying. You know, we'd say we could use it as a calibration method, you know, to test, you know, how good the laser is, but decided that, you know, you shouldn't be doing target practice with the laser while the helicopter is flying, but, you know, find a little bit of insight there. So Mars 2020 also has several sets of microphones on it. It's actually a pretty, let's see if I can move this way. Okay. Mars 2020 is a good listener. So it'll carry microphones that we can actually hear the sounds of Mars. So because Mars's atmosphere is so thin, it's really hard to hear like what wind sounds like. InSight has cameras, or InSight has microphones on it. So we've actually been able to hear what a wind gust on Mars sounds like. But Mars 2020 will carry these also, and we'll be able to hear some of the EDL sounds as the system is landing, because you'll actually be able to hear the rockets. So we record the sounds of Mars, adding dimension of our exploration of the red planet, which is kind of a nice little outreach thing to be able to, like, you know, we take pictures on Mars and, you know, we get to see what a new place on Mars looks like. But now we get to actually hear what that region on Mars, you know, sounds like. So the SuperCam and one of the other land cameras have mics, so that's kind of cool. So it records the sounds of landing, like I said, and SuperCam mic is on while the laser is on. So it's going to record the pop of the rock being studied when the laser hits it and captures that recording for a few minutes at a time. Possibly the sounds of the rover as it goes about studying Mars. So it's going to be kind of neat. You know, we have a lot of these neat little devices we didn't have on Curiosity that kind of add a new dimensionality to the rovers, that add to the context of the science that we're trying to do. So I have a fun little video here. So the robotic arm is how we're able to scoop, drill, and study rocks. Here's a video of some of the arm testing we were doing in the high bay. And for those who have never been to JPL or have never done integration and test of spacecraft, those garments that the engineers are using are called bunny suits. So the bunny suits are meant to keep the sweat and the hair follicles and the dead skin cells from the people working in there from being blown off and getting onto the rover. Because again, what we're trying to do is we're trying to detect life on Mars, and we certainly don't want to potentially get some of our life into the core samples that we then say, oh, look, we found life. But was it there to begin with, or did we take it with us? So this is meant to sort of protect the vehicle. It's basically meant to protect our germs from getting onto the vehicle. So let's move on here. So like the SuperCam, this SHERLOC and PIXL instrument is a rock analyzer. They can be used to study and map areas as small as a fingernail and gray-tail to uncover the origins, the history, and the structure of rocks. And that's very important when you're trying to understand the context of the region you're studying and whether that place is a good candidate for potentially a core sample for biosignatures. So together they can study areas, this is as small as grain of salt, SHERLOC and PIXL, SHERLOC, sorry, I've got a lot of notes here, so I'm trying to say as much as I can without going too verbose. So SHERLOC and PIXL see the larger picture behind the rocks they study, its origins, history, and structure. So the information collected with the Mastcam-Z, the SuperCam, and RIMFAX, RIMFAX is a ground penetrating radar that we'll talk about in just a second, leads the rover to interesting rocks or outcrops. Once it finds an outcrops, it wants to study in detail the R most of. So we talk about with systems functionally allocating our science requirements of different instruments. So you don't need one single instrument to perform one science objective. So we have multiple instruments that can perform a single science objective. And we take all this information and we aggregate it together, and it gives us the context. Geologists, for someone who haven't worked with a geology team for many, many years, context is about the most important thing they always emphasize with the regions. They need the entire context of what this place is in terms of the geology, the ancient past, the climate, all the things to put a picture together of what this place was once like in its past. So in its belly, we're talking about now what I think is the single most important instrument on this vehicle, which is the sample caching system. This is the system that we use to core sample, seal, and store on board for potential retrieval by a Mars sample return architecture. So it consists of three separate robots, three separate robotic mechanisms. The first one is on the end of the arm, and it consists of the core sample. Right here, we find a rock that we like. We're going to core sample this. not very big, about a 3 to 4 inch core sample. It's not much. So that core sample then goes into the transfer robot. So this white thing here, that is the sample caching. That's part of sample caching. So within this device, it rotates the sample down into the belly of the rover. And then this third robotic mechanism takes the core sample out. It's going to pack and seal it. And then it's going to put it in a storage container. So this device here, this is how we seal the sample. And then we image. I believe the level 1 science requirement is to score 20 samples. We have, I think, 30 sample tubes on board. So they're very precious. We have to be very careful with which ones we're going to take. But for 20 samples required, that is the one instrument that has given us probably the most headache and the one that has to absolutely work. If it doesn't work, then the whole Mars sample return potential architecture we're developing, it just doesn't work. So very important piece, very important instrument, one that has received a lot of attention at the lab. So next we'll move on to what I think is, from an engineering standpoint, one of the coolest instruments on the vehicle, and this is MOXIE. So the rover has an instrument on board that converts the carbon dioxide in Mars's atmosphere to oxygen. So I like to think of this as a lot of, when I give talks like this, a lot of people have seen The Martian and they know what an oxygen reclaimer is. So the device that Mark Watney uses to turn the carbon dioxide in the atmosphere into oxygen that he can breathe. MOXIE is a tech demonstration instrument that was developed at MIT that is going to actually do that. It's going to put electricity in, it's going to take the carbon dioxide in the atmosphere, and it's going to turn it into oxygen. And this is sponsored by HEO. So as NASA's preferring human exploration of Mars, MOXIE will demonstrate a way for future explorers might be able to produce oxygen from the Martian atmosphere for both propellant, so making our propellant on the surface, because when you have to land your propellant, you have to store it. That's a lot of mass. Why don't we just make the propellant there? So this is a way we can make propellant and also for breathing. And then as someone asked before, this is the Mars helicopter Ingenuity, just got a name yesterday. So we're going to carry this little passenger, and this is also a tech demonstration. It's a little CubeSat with these 2 counter-rotating carbon fiber blades, and it's going to demonstrate robotic flight on Mars. So a way that we can help with driving much further distances each day. The limitation we have is based on how far we can actually see. So if we can't see very far, if we can only see maybe 150 meters ahead of us, that's about as far as we can actually drive per day. But if we have something like this little helicopter with a camera on it, we can take more images of the area around us at much higher resolution than we could get from orbit. We could take that information and we could use it to build a longer drive path. So say we could drive as far as 600, 700, 800 meters per day. That's a paradigm shift in the ability to drive on Mars. So we don't actually use this to do that, but it's a tech demonstration. It's meant to just demonstrate that we could actually do something like this. We've done tests with this in the TVAC chamber at JPL, and it does fly, it does work. Those blades, to give you some context, have to spin at 60,000 RPMs to generate a little more than about 2 pounds of thrust to lift this thing up and actually fly. So it's going to be a really cool demonstration. I know that other than the EDL cameras, this is probably the one thing that all of us are most interested in watching, because seeing something actually fly on another surface on Mars, especially Mars with its thin atmosphere, this is going to be something really cool that everyone's going to really enjoy to watch. So this is the helicopter mounted on the underside of the vehicle, so it's mounted on the belly. I think our requirement is to only do 2 or 3 flights. We may take it a little bit longer from us, but the problem being you can think of the helicopter as kind of like a dog on a leash, and it kind of limits how far we can go, because when it's behind us, we have to stop and let it fly in front of us or get nearer to us so that we can actually keep going, because that's the only way we can communicate with it. So they're only required to do a couple. They're only required to do a couple flights, but whatever they're going to do, it's going to be really interesting. I know I'm really looking forward to seeing this fly. Another instrument we have on board is called RIMFAX. So something we haven't taken to Mars with us in a while is a ground penetrating radar. So this allows us to see the geological features such as sand, rock, or ice that are underneath the surface. And you know, a claim that a lot of geologists have made about Mars is that there is potentially a lot of water on Mars. It's just buried underneath the surface as permafrost. So it's under a couple feet of soil that we'd have to get to. So this ground penetrating radar maybe be able to tell us, you know, that permafrost potentially subsurface is maybe prevalent there. That's something we could use for potentially, you know, making our own water on Mars. So that'd be a very important thing. But for our purposes, it's meant just to tell us sort of the geological story underneath the ground within a few feet, just to kind of give us a little bit more, again, of that context of the region that we're studying. So the launch window opens July 17th of 2020, which is, let's see, June, July, about 10 weeks from now. So we're very, very close. Touchdown in Jezero Crater, oh, so close, February 18th. Touchdown is February 18th. So the neat thing about this is that our launch window is about 3 weeks. So from July 17th to about early August. Regardless of when we launch, our arrival date at Jezero Crater is the exact same day at the exact same time. That's because we have a little bit more, we carry some more propellant with us to account for the extra delta V we're going to need to arrive at the same time if we launch a little later. So regardless of when we launch within that window, we're going to arrive on February 18th. So the spacecraft travels about 354 million miles and it approaches Mars at about 30,000 miles an hour. So you can do the approximation. The V infinity is somewhere about 3.5 to 4 kilometers per second, which is pretty typical for a Mars approach. So this new technology we have on board, which is another tech demonstration, this is actually something that human exploration is going to be using for the lunar lander systems that were just announced this week, is a technique called terrain relative navigation. So the way that this process works is on board we have a computer that is taking images of the surface. And it's going to compare those images to orbital images that we have a plethora of on board. So we're going to have a database with all these orbital images of the region that we're studying. And it's going to compare the images that it's taking to the onboard map. And if it sees that the location that the rover is potentially going to land on is a little too hazardous for us, it's a little too rocky, it's a little too steep, it's going to divert the system away from that area and pick a safer landing location. So we've added a lot of autonomy to the system. And that's kind of the name of the game as we go further and further into missions like MSR and with HEO missions is autonomy, resiliency, resilient engineering. That really is something that NASA is pushing heavily, is that we want our systems to become more resilient and more autonomous. So this is one of the technologies that we're demonstrating on Mars to do this. And I'll note that the only reason we're able to land in Jezero Crater is because of terrain relative navigation. Jezero Crater is a little bit more rocky. It's a little bit more steep than some of the other places. And without TRN, we couldn't safely guarantee that we could land here. And safely guarantee, everything's statistical. So safely guarantee means our landing chances are greater than 97%, I think is how Andy Chen, who's the EDL manager, for Mars 2020 stated. It's greater than 97%. So it's a pretty high probability. You know, there's always some unknown probability and risk that we just can't account for. But it's very high, and that's the reason why we can land in Jezero Crater. So similar to Curiosity, we're using a descent stage to slow us down, and then we use a maneuver called the sky crane. So this is a computer animation of the sky crane maneuver for Curiosity. So we have the rocket backpack that we're held to, and then we descend down on 3 lines, kind of like a pulley system. We descend down, there are pyros that fire that release the wheels so they go into place, and then we get confirmation of touchdown, and we have to wait. So there's a signal on the computer, it's called Tango nominal, Tango Delta 1. So we hit the ground and we have to wait a couple seconds before the spacecraft, the rover, sends a signal to the descent stage that it is safely on its wheels and it's stable. That then fires a pyro that cuts the wires, cuts this electrical umbilical, and then the descent stage flies off and crashes away from us so that we don't smack down on the rover and, you know, destroy it. So that technology is the same as last time. So the prime mission is about 1 Mars year. It's about 1.5 Mars years, roughly 2 to 3 Earth years. So natural steps for Martian exploration. So this mission will explore a diverse landing site, seek signs of ancient life, collect rock and soil samples for possible return to Earth, and then the big one that we always want to mention is pave the way for human exploration. NASA is going to Mars. The question is when. So the current space policy directive from President Trump is that we will land humans back on the surface of the moon by the end of 2024, and that gateway will create a sustainable human presence in cislunar space by 2028. That is the plan right now. And then go off to Mars sometime in the 2030s. So the goal is still to go to Mars. The question is just when we're going to do that. So I'll leave you with this last video here. This is of something that's always very fun for any mission, especially a rover mission, is the first drive. So this was the first time we put the system on its wheels and drove it with the mobility system. We tested the turning capabilities. We tested its ability to drive over steep obstacles. We're testing the rocket bogey system. It probably won't be able to see it in here, but there was about 150 people in the viewing gallery that day because, you know, this is very exciting. This is, you know, for some people, they've worked a decade of their careers to get to a point to see this vehicle actually move. So it's a very emotional time for those of us who have worked on it. A neat little fact I'll point out here is those wheels that it's driving on, those are not the wheels that go to Mars. Mars's gravity is only about 1/3 of it is on Earth. So we actually beef up the wheels so that we can do the mobility testing on Earth. And then once it gets to the Cape, those wheels are taken off and we put the actual flight wheels on board. I saw a question here. So Holger had a question about as the Viking lander color cameras in 1976 have been tested under sunlight on Earth, were similar tests done with the Perseverance mass cam. So yes, we have some facilities here on Mars that we can actually test. We test the cameras under Mars light. So we have these big halogen lights in a facility we call the In Situ Instrumentation Laboratory, so ISIL. And we basically turn on all these halogen lights, and that's how we can simulate Martian light on the surface. So yes, we do test things in as close to reality and as close an actual environment as to what they're going to be on. So this test was supposed to start at about 9 a.m. on the 9 a.m. Here in California, and I don't think they actually drove until about 4 o'clock that afternoon. When you're getting a test ready, there was problems with getting the rover set up. There was problems with getting the camera set up and everything. So, you know, it just took some time. That blue stuff on the tracks there, that's static dissipative material. So the one thing we didn't want the rover to do is we didn't want it to build static charge up as it was climbing over these things. So that's just meant to dissipate the static electricity on the vehicle. I think that is my last slide. So I'm going to stop sharing here. Okay, so Marilyn had a question. How are the samples returned back to Earth? So the system that we currently have in place is called Mars Sample Return. And this has been an architecture that has been studied off and on for the better part of the last 30 plus years. So the architecture in its current format is it's a 3 launch architecture. So Mars 2020 Perseverance is the first piece of that puzzle, and it is to go and cache those samples and leave them on the surface of Mars for eventual pickup. The next piece of the architecture is a system we call the Mars Sample Lander. So Mars Retriever, MRO, Mars Retriever Lander, something like that. It's basically a lander that is being built by JPL. And on this lander, it has a Mars Ascent Vehicle, so it has a rocket that's going to be built by the Marshall Space Flight Center. And it has a fetch rover that's going to be built by ESA that we deploy onto the surface. That rover goes off, it grabs the samples, it collects them. That's why we call it a fetch rover. It fetches those samples, it grabs them, it then brings them back to the lander. It places them on the ground in front of the lander. The lander has an arm, the sample retriever arm, the SRA acronyms, it's NASA, we love acronyms. Takes those samples, it places them into a sample container. It then puts it on top of the rocket. It lifts the rocket up. It fires the rocket. That rocket goes into Martian orbit to rendezvous with the third piece of the architecture, which is called the Earth Retrieval Orbiter, that is being built by ESA. So the ERO rendezvous with this container in orbit autonomous rendezvous, because with Mars, things are up to 20 minutes away one-way light time. So we can't do this in real time. So the spacecraft has to do this all on its own. It's going to grab those samples. It's then going to spiral itself out of Martian orbit on a trajectory for an Earth intercept. And then there is a capsule on board that is being developed by NASA, so JPL, that the samples are going to go into. It's going to enter Earth's atmosphere, and then it's going to land in, I think, the salt flats in Utah. So that is the proposal right now. Let's see, another question here. How will NASA prevent the rover from losing power? So the rover, the power supply is from a radioisotope thermoelectric generator, an RTG. And that RTG creates power by converting the heat given off by the radioactive decay of plutonium-238, which is a non-weapons grade form of plutonium. It converts the heat given off by that and converts it into electricity. So an RTG, the half-life of plutonium-238 is something around 78 years. So we reasonably have power that is, we have enough power to run all the systems on the vehicle for up to at least a decade. I think Curiosity is now, Curiosity's been on the surface of Mars for, it'll be 8 years in August, and it still has plenty of power to run all of its instruments. So it can't run all the instruments at the same time, but it has enough power to keep all the instruments running. So it's a good power supply, and it's the only real way we can guarantee that the mission can survive for up to 2 years on the surface. So that's the only way we can do it. That's another one. For the pickup and return of the samples, let me go look for something here. For the pickup and return of samples sent back to Earth on a spacecraft, will the storage temperature be comparable to that of Mars? I.e., could drastic changes in temperature potentially affect the entirety of the samples? On a spacecraft, the storage temperature would be comparable to that of Mars. So the storage temperature, the samples will be collected at whatever temperature it is we collect them on, and they're going to go through thermal cycles just like everything else on Mars does. Could changes in temperature potentially affect the integrity of the samples? I don't know if I am. I don't know if I'm particularly in a position to answer that. I actually don't know the answer. Yeah, I'm going to choose not to answer that because I actually don't know the answer to it. So anyone else have any questions? Okay, Jim is asking, is communication to Earth direct or through a relay? So it's actually both. So the way that we upload commands to the spacecraft is through the DSN. So we do direct to Earth X-band into the rover's X-band antenna. And then the way that we get our data back is we relay it through a UHF relay to the Mars relay network. The Mars Relay Network, which is composed of Mars Odyssey, the Mars Reconnaissance Orbiter, and the Trace Gas. The Trace Gas Orbiter, and I think Maven and a few, and I think one other that I can't think of right now. So the data goes up via UHF because it requires less power and we can get more bits sent up on that. And orbiters are usually in view more than the Earth is because when it's dark on Mars, we can't actually see the rover because it's on the backside of the planet. But the data goes up UHF to the spacecraft, and then it's sent via X-band to the DSN. So it's almost like a bent pipe a little bit, but that's the system that we have in place. And it's worked very well for us, so that's the one we use. What is the favorite part about my job? So the best parts about my job, well, I got to fly spacecraft around Saturn, so that was pretty cool. I got to be the flight director for a Mars rover and got to go through the entirety of the dust storm recovery for opportunity. So that was pretty cool. I'd say the best part is getting to work with all the really amazing engineers that work at JPL, because everyone is as excited about the missions and the work that we do as everyone else. So the level of enthusiasm that everyone brings to the work, and again, the type of work that we get to do is, I think, the best part of the job, because everyone is just as much a space nerd as the other person. Let's see. So David Sunderland asks, does the rover still have to function when the fetch rover arrives? Perseverance will continue on its as long as the rover is still healthy and we can continue operating it. Perseverance will continue on likely an extended mission even when the fetch rover arrives. Basically, once it drops those samples on the surface, it's going to go off and keep doing its mission. Now, if there's a case where, again, MSR isn't funded right now, so there is no mission on the books to go get these samples. But if MSR was delayed for some reason, Perseverance could go off and could collect more samples in a different region and potentially go drop those off at another place on the surface, or could drop them at the same location. So we could have potentially core samples from multiple sites. Don't really know right now, but the plan is that Perseverance will continue, just like Curiosity. After its prime mission ends, it will continue on doing what it's doing. Typically with NASA, as long as the spacecraft is still healthy, we have lots of consumables left, the hardware is still good, we'll continue operating the mission until we can no longer operate it. Okay, Doug Stewart asks, is it always necessary to crash the vehicle that delivers rover to the surface? Would just landing it safely to have it there for the future and yet to be determined uses be an option? So I'm guessing you're referring to the descent stage when we crash it. Because of the descent stage, the only function of the descent stage is to get the rover down to the surface safely. Once the rover's on the surface, we have to guarantee that it can't contact the rover again. So the only viable way that we can guarantee that is we have to have it fly itself away. There's no real way that we can prevent it from crashing because it's rocket powered. So as soon as it detaches, we command it to fly as far away from the vehicle as possible so that it doesn't impact it again. There's no real other way for us to land to recover it, and there's no real function for it after it's got the vehicle on the surface. Okay, Arpi asks, what do you think will be the future of exploration to Mars? If you could go back in time, would you do something different based on your work on this mission? What do I think of the future of exploration of Mars? So I think what we have done so far has been a very logical progression in answering the context of, was Mars once, could it once have water on its surface, which is the first piece you need to know if life was there. Did it have the right climate? What's the interior geology look like? Up to the point of, now do we think there is a place where we could potentially find life? I think that the progression in answering the question has been very good. It's been kind of slow because NASA budgets are not very big, and we have to work with what we have and also manage a portfolio of a lot of different other missions. So I think that the path we've been doing is very well. What I think the future of Mars exploration for robotics will be after this, the next one is Mars sample return. I think what's going to happen beyond that is I would think that the next step for us is to upgrade the relay infrastructure at Mars, because we're preparing for humans to arrive. So we need to get the relay, we need to get the communications infrastructure probably updated a little bit so that we can support human missions. I think the next big exploration mission for us would be an ice mapper mission. I know that it was proposed in the budget this year, is an ice mapper mission to actually look for places where there is potentially concentrations of permafrost underneath the soil so that we can land human missions there, and then they have an ample supply of water to live off of. So next question, will you continue to have these calls as the launch date gets closer and even during the mission? So calls as in like presentations like this? I'm not really sure the context of the question. Yes. So I can certainly, if there's interest, I can certainly keep providing updates as to what's going on at the launch site, and as we get closer, if there of course is interest for this. All right. Any more questions before we move on to the next speaker? Going once, going twice, and sold. All right. Shawn, it's all yours.
Yeah, thank you, Michael. Thank you so much.
Thank you, Michael. Hey, did you know Dr. Ron Barrett from Wichita?
I have heard the name, but I don't think I've ever met him.
Oh, okay. Yeah, he's a friend of mine. We did a conference in 2013 together. So, how long have you been at JPL?
I've been here for 4.5 years. This is my last week with the lab. My fiance got a promotion and a transfer out to Dulles, Virginia. So we will be moving out there here within the next. We're moving out here within the next 2 months. So yes, it's kind of it's a little bittersweet because I have loved working at the lab. But, opportunity comes by and it was too good for her to pass up. So we.
Yeah, you still have Goddard and you have headquarters over there. So
well, I can't particularly complain because the program I got hired onto was the lunar lander that Northrop is in with Blue. So I get to continue working on NASA missions even if I'm not at JPL.
Terrific. Congratulations. Great job, by the way. I hope you have fun and congratulations. Where are you going to get married? Over there?
We're probably going to do it here in Los Angeles if the courthouses ever open up.
Again, great job and congratulations.
Yeah, thank you. And to Shikar and Ken, if I can certainly provide updates on the mission as we get closer, if there is interest in that.
Yeah, of course. Yeah, and you will be presenting this Cassini mission, June 6th, and during the launch site, Sheikh and I will get you, for the course, for the status, those things.
Yep, very good.
Thanks again, Mike. Okay, shall I take it away, Ken?
Yes, go ahead.
Okay, thanks. Thank you, everyone. I know we tried this back on April 18th, and now we're going to do it, and I'm hoping to get through it. I'm going to go through the front end quicker and save a lot of meat and potatoes as we get into the details of this. And so the Future Space Force, this one, if you notice, the Space Force is actually just now becoming a viable entity. So in 2020, okay, they only get to hire 200 people. So this front screen, I put the link on it in case you don't have the slides. They're available up on Scribe. That's what the White House uses to put presentations up. So as we go through this, one point I'd like to say is I'm an official advisor to the White House, Senate, and Congress since 1995. So as I do this presentation to you and a lot of my industry experts, if you have feedback to do the planning for what the Space Force should do strategically, I'm giving this report with a lot more details to the President, the Vice President, and the Department of Defense. So anyway, any input you have would be very valuable. One thing I'm noting here is the link, and I have studied the future of aerospace and the world's future. A lot of things I talk about will be speculative, based on not just my knowledge, but a lot of the industry experts, the defense intelligence agencies, and people that know what's going on. So I'll bring up a lot of links. So as you see in my presentation, I put a lot of links in there. You're welcome to go back through and and check them out. It's very important that you go and do your homework and look at all the details. Just don't believe what a guy says. Go and look at the details. So that way you'll understand a little bit further. So as we look at the agenda, I'm going to first talk about the creation of the Space Force, where it is, and what's scheduled to happen. The threats and what's defined as the threats, and I'm going to be looking at what we call the space threats. And there's two different departments I'm looking at: Defense Intelligence Agency, the U.S. Space Command Center, and also a person that was actually in charge of the Air Force and space and threats. Also Michael Pilsner. So I'll show you that there's three threats. I'm going to explain those. And then the meat and potatoes of how do we make this successful with different concepts. Right now, there's nothing documented for them, okay? So I'm going to use unclassified information. Some of the details, you'll see ships that are very classified, but that's about all we'll talk about. I'll talk about the space economies and then a conclusion. So I'm going to round out the whole presentation that way. So the key points for the Space Force, there's these 5 important points. And that's, of course, transform the combat support and warfighting domain as being a space, because you got land, sea, and air. Now we have space. So this is just completing and rounding out the entire atmosphere of defense, which you needed to do. So Trump did well. So anyway, as this is under the Department of the Air Force, which used to be, remember, it was the Army Air Corps. So now it's the Air Force, and now it's Space Force under the Air Force. It's actually to do warfighting capacity and the advocacy while minimum. So if there's a real space problem and threat up in space, to try to take the politics out of it, whether it's from different nations and then you have the political lobbying about it, we're trying to take that out and define it as what is a real threat and how do we handle it at the DoD level. That's really important. Some things get too politicized. Try to get rid of that, lower it down. And then outpace our competition and re-energize the DoD's space avenues, and then try to do it at a low cost. It's very important. How to innovate and do it at a low cost. I'll explain some other details later. And then a full-time operational focus to defend our vital interests in space. So that really includes having a continuous space presence. So you'll see that I have the PDFs listed here. This is actually org chart, the new org chart for the Secretary of Defense. In red is the U.S. Space Force, okay? It is run by a civilian supervision of the Space for the Space Force. It'll be the creation of the entire Space Force. Right now, they're allowed to hire 200 people. They only got 40 million out of the 70 million asked for. And they do plan on having around 16,000 personnel. That'll be by 2024 and afterwards, okay? And then this is going to be, then on, it's privately DoD funded. So that's the explanation of that one. Now, what is its actual problem statement and what does it have to do? It's actually, the United States is at risk of losing its comparative advantage in space by our competition or our advocacies. So which would be, right now it's defined as China, Russia, Iran, North Korea. Those are the main ones. And then also to assure the freedom of operation in space, to deter attacks, to defeat adversary attacks, which they do have some, and then counter space threats for our national security interests. I'll bring up some that you'll see. And then also, it will be responsible for, of course, just like all other DoD branches, is to organize, train, and equip for the Space Force. We know it's now all space domain. So there's things that NASA do, which is explore and adventure into and things like that, but they don't do defense. They actually used to have a branch and that was in the 80s. And that NASA branch actually did help us in the DoD. So now we have a separate force to do defense, because it is a very important domain to worry about. So, and then also the freedom of operation in, from, and around the space domains. You'll see that some of the threats are trying to control the entire space domain, and then provide lethality and effectiveness as a joint force in outer space. It will also include both combat support, enable prompt and sustain offensive and defensive space operations as joint operations in all domains. Okay, so it actually has, in space, it actually has to help here on land and sea, okay, and in air. It will help the other guys too from outer space. So actually, it's just a full rounded flavor of the whole DoD. So now, from our statement about we're losing our comparative advantage, okay, we must assure freedom of operation in space and to deter attacks, defeat our enemies, and counter space threats, okay, very important. So number one, our adversaries and enemies are focused to dominate the world, okay, by winning space and own all its economic advantages. They want to own all wireless energy, okay, like 5G and on, no more landlines, space transportation, okay, they want to conquer maneuverability in space, okay, and also the information and communications, and then space manufacturing. These are the four main domains, okay. So threat number one are those four domains. The space debris is a huge problem. It could destroy anything in its path. And it has actually wiped out some satellites. It actually broke the windshield of the space shuttle, and that's under a centimeter, okay? So there are a lot of problems with space debris because it's a space domain. That's still a threat. So, and then attacks to the US. Another one would be like solar flares. We actually have an EMP group by Peter Pierce, and with our EMP, part of the White House Secretary of Technologies. So EMP and upper atmospheric nukes, okay, that's a major threat, and it's very apparent, and it's only going to become more of a problem. Now, this is a very cool, what I'm going to get into, I'm going to go through these next slides, but one thing I really want to hit is Stephen Quast actually had to quit the Air Force so he could tell the world about the real problem and the real threats out there and why the Space Force is such an important activity. So this multi-star general of the Air Force, which used to work out of San Antonio, he has a great video about the need for the Space Force and the urgent need and our threats. So he reads all the different classified information coming from China and other Russia and so on. So now overall global, I got to talk about the economies of how important space is for the future. Okay. The overall economy of the whole world is around $80 trillion. Okay. If nobody ever taught you that, that's what it's worth. If you could sum up the whole world in an economy, 80 trillion, okay, in a year. Energy is around 18 to 19 trillion a year. And we have 2 trillion barrels of oil in reserve. Information and communications comes in number 2, and that's 6 trillion a year. Transportation, automobiles, aircraft, everything is 5 trillion a year. And actually in all land type vehicles, trucks, cars, 74 million units a year are being produced. Manufacturing, which is all the above. How do we make everything for all the above? So those are the 4 economies of an entire world, and believe me, China, Russia, they all want to dominate that. Our biggest threat is China. They are really going after this aggressively and using other people's money to get there. So, and they take advantages where they can. So you got to watch Stephen Quast's video. You'll get the most out of it. So the important, I'm going to boil down his 1 hour presentation in just 10 minutes or less. So the important talking points here are: beat our enemy at dominating the world via space and all its future economies, the four I just listed. Create and dominate in a wireless space power and energy. Make space transportation safe, maneuverable, and a commonplace. People should be able to, in the future, they will be going up there to hubs and have better shuttles, space planes, and ways of getting there and coming back as almost like a flight was back in 1960. Okay, it should become normal place in the next couple of decades to be that way. We know China wants to dominate the whole world by 2040. So they wanted it sooner, but it'll probably be 2040. So that's their goal. Have a continuous space presence and space hubs. Create space manufacturing and construction as a commonplace for future growth, because the economies out there exceed what we're doing today. So now I'm going to boil his 1 hour thing in 12 points. I think I had it. Why there's the need for it: the historical technology of world power and firepower. You had the power of fire from a caveman. Then you had, the wheel, and then you had automobiles, and then you had the airplane, you had the nuclear bomb, and space is going to change the world power. It will make interballistic missiles an absolute thing, obsolete, I mean. In the future, when you can zap things from outer space and transcend things, get up there and back again, our old ballistic missiles and our rocket ships are going to become old hat. So I'm going to talk about some other future powers here. So anyway, that's very important. The power of space and what it can do to be the new and largest world power. It's going to be the economy of the future. Like there'll be no wires for communication. You won't have a cable TV in the future. So no wires, okay? A location, okay, and he likes to talk about from the beginning. At a location, a country or a tribe can get trapped and stuck in its own world paradigm, okay? I think he brings out different avenues of how that happened, and I'll bring up the British one now. So we must own the means for optimizing standard transportation, economy, and dominance. So space as an economy, we have to dominate, okay? For different war type things, the British used to have the best Navy fleet, and they had gunpowder and rifles. That's how they dominated most of the world. Well, before World War I, they just rested on their laurels and said, okay, all our brave men with their rifles can defeat anyone. Well, little did they know about the Gatling gun, okay? They didn't look about the Gatling gun or chemical warfare. So they got their butts kicked. Okay, in World War II, they still didn't evolve, and they got their butts kicked. So because we actually had developed the nuclear bomb, and we could have taken over the entire world and planted our flag across the whole world, we didn't do it because we're not that kind of society. America doesn't do that. We actually just said, okay, there'll be one monetary international means. And so the dollar, the US dollar, was the only internationally traded currency, okay? Everyone else got to keep their sovereignty, but our US dollar was strategic, and they all had to sign to it at the end of World War II. So now I'm going to talk about, like, okay, he talks about how technology is not always about technology. It's also about the strategy, okay? And that's Sun Tzu. A lot of the technologies we used to have for SDI, Strategic Defense Initiative, which is Star Wars by Reagan, held on with Bush, all of that, a lot of it didn't exist. The physics of it didn't exist. Now we have new technologies on the desks of scientists everywhere. So it's amazing what we've evolved from. So the interest, okay, make this place to produce power Those who make it rule the world, okay? There was a study done by Bush Jr., and it was a war without oil. So whoever ran out of the output of this entire 130-person PhD study proved that whoever had the ability to produce, which is energy and manufacturing means, which means the power to keep them producing, they win the war. They dominate the world. Well, because oil was the major means of energy, what came out of that was, okay, what about the space solar power? NASA had it. They did that over 50 years ago, came up with it. And they actually had a group led by John Mankins looking at doing that. And then, so Bush went to him and said, okay, what about the space solar power? Well, NASA said, well, we don't do power. And then they went to the DOE and they said, well, we don't do space. So they just said, okay, what do we do here? So then they kind of dismantled the space solar power stuff at NASA because they kept pointing the finger to somebody else. Okay, well, this comes in for the Space Force. This is the most perfect avenue to control power. Okay, there's a lot of means for it. So anyway, make space a standard manufacturing economy with materials and process, 3D printing, and so on. When there is a new marketplace up there, you need guardians because there are always going to be pirates and thugs and those who want to be tyrannical like the communists and just dominate. Okay, so we do need a defense. You have to have a defense group. Thanks to Elon Musk and also Zuckerberg, they're doing a 12 to 13,000 satellites, and it'll become a wireless worldwide Wi-Fi. Okay, cables and landlines will no longer exist, and it's called Starlink. So you guys probably all know about that. So the one thing that that General Quast was talking about is, think of this as a car race. We're heading in the leading car, cruising at 90 miles an hour. China and Russia is on our bumper. And their car could do 120 miles. Okay, we've been doing 90 miles an hour since World War II. We've made it so the car is dependable and perfect and great, but their car behind us could beat us. It's not as good as ours. It's not as dependable or reliable, as well refined, but eventually that car could pass us and leave us in the dust. Okay, very great way to look at what the Space Force has to look at. So China, our advocacies, China and Russia does know this, and they are in a rush to get up there. Just like we have to consider this as like battleships, okay? They actually have other weapons up there. So we have to think of this as like a space navy, okay? So what would it take to maneuver up there, kill, and communicate and dominate, okay? So China openly stated that they will weaponize all the technologies based on space technologies, on energy and communication. The next slide, he talks more about it. Right now, we only have, think of a satellite just doing its orbits. It's nothing but a space buoy up there. It doesn't do anything. Okay, the only way it has maneuverability is right before its end of life, it has to get out of the way so it doesn't create more space debris. Now that's been in the last couple decades, that's been a requirement because we have way too much debris. So other than that, we don't maneuver it. Okay, we might have to move it out of the way, push it every now and then, but that's about it. They're mainly just buoys out there in the water, which is out in space. So now the electromagnetic spectrum, like the 5 gigahertz, the 5G, that's the entire battlefield. And, you know, the enemy wants to dominate and cut us off and put us in the dark. So that's a very important battlefield. So the lessons, why didn't America start and control the 5G? Okay, this is a good lesson to us. 20 years ago, before China actually started it, China invited all the different companies like Lucent, Motorola, and Nortel and such. They had them come out and they put them up at the nicest hotels, wined them and dined them, made them feel like kings, and asked them to bid on this new system and providing communications for all of China. Wow, over 1 billion customers. This is awesome. So they gave them all this intellectual property, okay? That's what you do when you do a bid. And then, of course, China said, well, and they stole it, and they created Huawei. Okay, Huawei stole everything. They didn't have it before. It didn't even exist before. So they did it themselves, and they created it. So imagine delivering Wi-Fi and all communications and eventually energy to every person on the planet for only pennies a day versus today. And no lines on the ground. Well, that's their vision. So a country, say if like Germany and England now wants to add 5G, right? China will sell it for almost free, almost nothing. And they'll give them a discount of 90% of the launch cost. Most of the cost of putting your satellites up there for that domain is launching. So they're gonna bite it. Okay, China will bite it just to oversee that entire marketplace so they can actually listen in on everyone. Okay, well, we are currently dominant in space, but not for long. Now that China is dominating in 5G, we can do it ourselves. So since others have full out plans to beat us and doing it by using their country's economies to do so, that's a very important fact. Another fact was like this Wuhan virus. We have facts that in that area, you know, China makes sure that all their citizens get a government issued cell phone. And that's the way they can track and understand what's going on with their society. And if they should have any threats that don't follow their marching orders, well, they can take care of it. So there's, in that Wuhan area, during the Wuhan virus, since then, we have intelligence that proves 2.1 million Chinese phones do no longer exist. Now, you can make up what happened from it. I'm sure they're going to make up something. So anyway, President Trump wanted the Space Force. He's seen that it's a very important area. He did go to military school. All the bureaucracies howled against it. They didn't want it because, you know, the deep state says, no, everything's fine as it is, you know. We're in control, right? So NavAir has their own NavSats and everyone wanted their own. So typical. So anyway, they, fortunately, except for, we haven't won any world war since World War II. We've only signed agreements to not war anymore, except for Bush Sr., who liberated Kuwait in what, 30-something days? That's the only time we won. So that's a very important fact. So now China will lie, steal, cheat, and of course, to everyone to get their way in their communist goals. If you ever read their manifesto, it's written in there. So our grandkids may be speaking Chinese if we don't get on top of this. That's why this is so important. And it's not about the Chinese people. They're fantastic people, especially if you know them. They have fantastic food. It's their dictatorship and their politics that are dreadful and control and tyrannical. They make mistakes. They take them out to a field. You never hear of them again. So anyone that knows anything about China, look into it. That's an hour in a summary. So now let's define those space threats. Okay, space threats from China and Russia. They are these 6 that are shown here. You can see that I have a little picture of the DIA, Defense Intelligence Agencies. This is their space threats. A lot of this is defined in there. Russia actually has anti-satellite missiles. They've just launched some this year. China has also launched some. Russia and China has these laser threats to wipe us out and put us in the dark. They have lots of neutralizing space satellites. They also have cannibalistic ones that'll go over and maneuver into our satellites and actually destroy them in space. Okay, cannibalistic satellites. So I just tell you, these, you have high-powered microwave, okay, radio jammers, lasers, robotic mechanisms, kinetic kill, which is, you know, which is like a destruction one, and then chemical spray, like how do you wipe it out again? So all these threats exist. We got to be concerned about that. Don't be blind to it. Now, out of that, this one comes, I think, from Aerospace Corp, but this shows we are dominant in our satellites, okay? You can see on the side there, you have China and Russia, and then the rest of the world in purple. You can see where they have their satellites. You're welcome to look into this in more detail later. I won't define it more. Again, this is another definition of those bubbles of satellites. Communication relay, ISR. ISR is what you use for defense, basically. And then science and technology. So, and then the Russians one for communications relay and so on. ISR, again, intelligence, surveillance, reconnaissance. So I'm just saying, these are our major threats, and they are launching them all the time. Now let's talk about the threat number 2. There are over 6,800 tons of debris orbit floating around in our outer space of our orbit itself. LEO, MEO, and GEO. Only 23,000 are tracked objects. Most of them are untracked. Okay, there's 750,000 that are 1 to 10 centimeters in diameter, which are very dangerous, because the one that broke the space shield, the space shuttle's windscreen, which is actually your windshield, was thank goodness we have multi-laminated pieces, so it didn't penetrate inward too much, but it did crack it. It was only 7 millimeters, so a lot of destructive degree. And remember, most of these are moving at 20 times the speed of a bullet. Okay, so way faster than anything we've ever seen. There's 34,000 pieces larger than 10 centimeters, which means larger stuff, very large. And there's really this is the one that broke the windshield, 166 million that are less than 1 centimeter or 3/8. Okay, going at 20 times the speed of a bullet. It's a threat. And now we're going to talk about threat number 3. Big solar flares. There was one at the turn of the century that they didn't have much electronics. I don't even think Edison had the light bulb yet. And that would have, if we would have had a solar flare like that, and because the sun is actually more active right now, it's going to get even more as we age. This solar system ages, and of course it only gets bigger and more violent. So that's just nature of the world. And we will have solar flares that'll come in, and they can put us in the dark. And an EMP, or an upper atmospheric nuclear explosion, will put us in the dark for quite a long time. We are not prepared for this. Because I've done this work with the B-2 and Air Force One, military vehicles, anything newer for a while has Mil Standard 464C explains that type of problem, nuclear and also EMP. And then all grid systems, your homes, your healthcare, all transportation, commercial, everything will be dead, okay? And the study proves that 9 out of 10 people would be dead in a year. So, and now a story on this one, a threat that happened just a couple years, while Trump was in office. Actually, North Korea was sending a missile through the Panama Canal. It was a missile on a mobile Chinese rocket launcher that could actually move and lift up the missile to be launched. And it had a miniaturized nuclear head on it. And fortunately, our satellites caught it as it was going through the Panama Canal, so we stopped it. But that could have been up and launched over the head of our North America continent, and we could have all had one. And 9 out of 10 of us would be dead in a year. So this is a real accurate threat, and it does happen. Peter Pierce is one person that you can read videos on or watch videos on, and I think he talks about that in some detail. So now, what's the goal for the Space Force? Okay, assured freedom of operation in space. Okay, jamming things, maneuverability, deter attacks on the U.S. and our allies, defeat enemies in space and counter space threats, if there are some. And, I've just explained some that China and Russia are planning on, or they're doing it now. They actually exist up there now, and they sent up tests that they are going to blow them from outer space. down to earth stuff. They have them up there now. They're up there launched and they're doing these tests. And then prevent our enemies from dominating the world, okay, and putting us in the dark. Very key points. Now, our actions are beat our enemies at domination. All its future economies, those 4 different economies are very important that I mentioned in the front. Create and dominate wireless space communications and power, very important. Wireless space power still is to be looked at. There's a great study here by John Mankins, and it was paid for by us taxpayers. He got like $5 million. It's a big book, great book, and it's about you know, the case for space solar power. It talks about it talks every detail there is. That should be a common book for all colleges. Then make space transportation. I worked on the National Aerospace Plane and at McDonnell Douglas, and we made the fuselage that could handle that type of Mach 25 and take off and land at a runway. Okay. Fortunately, the technologies, we made it, we could manufacture it, but all the technologies weren't there at the time to make it a standard, easy thing. But we're talking 30 some years ago. So now we could do it. We need to look and readdress this type of capability. Anyway, have a better type of shuttle and space planes. Have a continuous space presence by having hubs up there. We need a space force continuously up there just to monitor and control and help. And in case there's problems, they can take care of things. So we need a continuous space presence. And then to make factories up there, like grab some of the debris and make and just ship up raw materials and make things up there instead of having them all built and send them up. We could do it up there. So anyway, these type of 5 things are very, very important to look at. So now let's look at what we have to address with Space Force. What they got new space satellites. Okay, they have some that are jammers, frequency hoppers, very important. They just sent that up this year. So this is the 6th of 6 of them. They started it in 2010 and they just got the last one sent up 2 months ago now. So, and then the SAR, they just put that one up. And then, so anyway, this thing will look at, it'll give you a virtual reality of moisture content, materials, properties, just like your Mars rovers do. Well, this satellite can do it for anything in outer space, on the land, or anywhere we want to look. So anyway, that's the technology. And then you can see that they want to do predictive intelligence. There's hyperlinked technologies that we can look at with threads and able to do predictive intelligence to look at threats and how the long term could turn out to be. Those in the Defense Department stuff who've done this know what I'm talking about. This is an unclassified arena, so I'm not going to talk anything about it. We do have the jammer. This is what I'm going to show you. Space Force now has this. March 9th it went up, and there was a ceremony at Air Force Base. So you can see what it does. Okay. All this information, you can get more details from the links I provide. Now, this is a survivability network. Now, if you were doing land vehicles, okay, this is for the Army's future combat systems. See how we have the outer shelf to avoid encounters, detection, acquisition, hit, penetration, kill? We need this exact same thing for the Space Force. So we are putting something together, and that would be classified. This is, as you can see, is approved. And this was way back in 2004. This is how we look at things, okay? See first, act first. So now, one great lesson, and a lot of it is available online, both YouTube, Google it, is the Reagan's SDI, which I did work on. The physics of most of them are now doable. They had one of it called Brilliant Pebbles that could just wipe out satellites from out there, just push things and wipe them out. Like if there was a missile incoming, a threat, a brilliant pivot could put that out. Okay, so there's a lot of stuff in there that can be shown, and I'm not going to go into the detail. There's just so many different things for SDI. You can read entire articles on that. Now, I'm going to go into more stuff. Let's look at space systems, system of systems for success. Okay, SOS means it's looking at the whole thing and then breaking it down to minor details and subunits and then different products and vehicles and ships and aircraft and so on. So now, United States, we need to beat our enemies from dominating the world. We've said that before. Create dominance in wireless communications and power, energy, transportation, safe, maneuverable, continuous space presence. I'm just reiterating exactly what I told you before. And manufacturing should become a standardized factory up there, and should be a standardized means for future generations. Now, here we're going to get into a little bit of meat and potatoes. I got some five concepts that I'm going to blast through. What's my time? 11:51. I'm going to try to blast these really quickly now. We should have space hubs and crafts. Okay, first you always have a command and control center. We should have a space presence up there. ISR, intelligence, surveillance, reconnaissance, defense and offensive system. So we need hubs. So these are the three things that we always think about. Ships, they all have all three. On land, we have all three. In the air, we have all three. You need the same thing. Power star satellites. These are what I'm working on, my group, along with Dr. Hyland and Dr. Werbos and other people. We're looking at some satellites that can do energy and communications, and then space tugs and tow vehicles. Very important. You need maneuverability out there. And then to handle threat number 1 and 2, you need to capture. You need capturing nets and webs and products that can actually maneuver out to certain things and grab them and take care of them. And then a spaceport factory and able to do manufacturing. We need to be able to grab like old satellites, debris, and disassemble, separate, and then part them out. You know, in a factory in space, you could just grind them up, centrifuge it, separate it by materials, and then you could start 3D printing right up there. So now we could use raw materials of debris that's already up there, meteors. We can do meteor mining. That's a space economy of the future that everyone's looking at. And then reuse by 3D printing. 5 main things to look at. Space hubs. I think Gateway Foundations, thanks to AIAA, they had a great one at Malaga Cove not long ago. And they had the Gateway Foundation talking about space hubs, and they looked at the Von Braun station, which I thought was fantastic. Their concept is very, very good. Great videos up there. And then, so if you look at the Von Braun, which you know, our ISS doesn't, you know, you're in a fall, so you're in a 0G because you're falling to Earth anyway. So it's not just staying there; it's falling to Earth, but you're in a 0G. That has, you know, as you know, it's detrimental to a human body and your brain. You just don't become a normal person after being a year up there. And that was just proven, okay, by Kelly. So we definitely need to do the hubs. I really liked the Bigelow. If you look at this pod in the center here that they have on the Von Braun station, that pod could be like a Bigelow pod, but I know they plan on building their own and shipping them up there on the BFR rocket with Elon, SpaceX. Bigelow ones could do this too, but we got to look at it. The government has to look at it and define exactly what the system has to look like, okay? And that's what we become part of. And that's, after this, that's what I write, and it goes to the White House and DOD. So, next one. So, the Von Braun, look at how small that is. And the entire Gateway Spaceport of what they really want it to be, which would be awesome. That could be 2040, 2050, whatever. Of course, I like where they have the center. It actually stays at a 0G, and the entire ring around it rotates. Okay, it should be that way. the center should actually be at a 0G. So when you're bringing in a maneuverable vehicle, it doesn't have to find the rotation and meet up with it, and then it has to stop to get the people off. Nah, it should be, so that should be a 0G center. And I think their latest concepts explain that in good detail. Now, we need to do space construction. Thank goodness, Big Gateway Foundation is looking in the right ways of looking at space construction up there, with different types of doing it. We should have 3D printing up there that isn't explained in their videos. There's a lot of other NASA things like doing Mars, moon bases and Mars bases by 3D printing from the raw materials there. And then Space Force crafts. These are maneuverable crafts for outer space. Great way to look at things. And most of these are, the details of them are classified. The space weapons, you can see them here. And again, most of those are classified, but I explain them and you can see pictures of them. You can find all this online. X-37's old, and the, what was I was working on? The X-25, the National Aerospace Plane. That's old too. X-51's the most latest one. It's the hypersonic wave rider, and then the Pendragon. So anyway, and the Russian hypersonic, you know how they were bragging about it? And Trump said, oh yeah, we have that stuff going on. We just didn't tell you about it. So anyway, that's theirs. On from there. Missile defense. Okay, eventually we'll make this a problem of the past. I'm cruising along from here. Energy from outer space. You need these main subhead categories to make it work. Okay, the 3 on the bottom: weather control, tracker beams, so you can go to different planets and exploration. If you create the energy with communications, you can beam it to somebody or somewhere, and that could be done at 5.8 gigahertz, and we know what to do. We could do this and desalinate from outer space. Totally doable. John Mankins was shown in the lower area. These are studies that have to be done. The optimal beam and energy, we already know, is 5.8 gigahertz. You can find those at the National Space Society's International Space and Development Conference, and I think I've put a bunch of them up in the internet places. This is what's known as the best solar cells. I think Elon said 28.8 or something was the best they could do for down here. Well, you can see Germany's got it at 46%, and that's because they're absorbing all the spectrums of light. So anyway, this is from the Department of Energy, and this is the true best solar cells and the technologies. This is the overview of what we're doing, our company with Instagrid. They're doing this Power Star, and we're defining all the detailed requirements for it. Our material, which is shown here, these exist on boats, Duffy boats, and we're going to make space satellites like this. This one on the bottom, you'll see the NASA logo on it. That's the first one. It was a 31 meter and then a 50 meter, and it was called the NASA Echo 1 and Echo 2. And this actually was launched in 1662, I think. And this was, you know, in regards to how do we beat the tiny little Sputnik. So we put up a monster and it worked. But see how it's miniaturizes? Well, the cool thing out of this technology is all your airbags in your car, okay, those came from the solid rocket propellant that's in there to actually make these inflate, okay? This was invented in the late 50s, early 60s, and we did it, and it's up in space. So it worked. And we'd use the same kind of concept, but we'd make it out of a solar microwave fabric. I'm going to blast through these details because we don't have time to go into them. Solar microwave fabric. It's solar cells printed on a very customizable composite fabric. There are some details of how it may be made. And it does wireless transmission, it does retro-directive transmission, and it's like a sonar. It hones in on its actual location and then fires back and forth. Raytheon's done it the best, and John Mankins personally did it in Japan. So we're still looking at all this. This is a reference of what that Power Star type of sandwich would be. of course, it's not going to be exactly what this is, but all the components there are important. You have your scrim cloth for EMP hardening, and then the composites. And okay, I can make this. This is the evolutionary of our fabric, okay? Right now we're in number 1, the EMP one. We're creating that too, which actually is this material with the Faraday cage built into it. So it's a self-powered Faraday cage, and it's like a tarp, and you put it over your transformers. For instance, there was 5 people in Sacramento that blew out a transformer and put Sacramento in the dark for 3 days. Okay, well, they came out with rifles and shot it down. Okay, they were terrorists, Islam, of course, and so they blew it out and shut down Sacramento. Well, we make this out of a ballistic-proof Faraday cage, self-powered stuff. Now you put this over all our power stations. There's like 23,000 in North America for us, US, and you put that in our critical areas. You also put it in our military and like health-saving areas that are very important in case of a solar flare. And so we own the patent on this, and actually once we put power stars in outer space, we could beam it right down to the energy centers onto this material. So it's cool. It's got dual usage. The Instagrid is, again, the solar microwave fabric that can be used for a lot of other things. I like this airplane up here, this guy right up here. And then you can see Power Star is the ultimate technology that we're pursuing with the Space Force. This originally was done with Dr. Hyland, and I met in 2013, and then afterwards, I think 2015, he conceived of this, 2014, 2015, he conceived of this, doing it for asteroid, and then also sending energy down, and we could send it to each one of the satellites. This would be a 100-meter diameter space satellite. You see 3 of them, but they could send energy to each other, and they could focus in on one location, and at the speed of light, vaporize. Looking at super, super low power densities of like 1%, this could wipe out a 20 metric ton meteor, okay? Now we're in the upper 20s for this type of material. And and our first launch would be 3 of them. So that way they self-balance, and they have to self-balance because every time you send energy, it pushes itself with 1 joule of energy into a higher orbit. So very important thing you have to do, be concerned with. So you have to send energy to each other to keep you in a planar area and your own localized orbit of where you want to be. There's a lot of science to this, but this would be a missile defense, asteroid depleter, so on. All right, Space Force number 2 threat. Capturing nuts. Very important that we do some capturing nuts. There's a lot of stuff on capturing nuts. For smaller debris, you capture, you tether it, and you bring it back and you use it. I say we repurpose the materials. Come on, baby. Okay, now, this is of course from NASA Glenn's asteroid capturing technology, but we could use this. We could use this for not just asteroid grabbing. We could grab old satellites that have been outpurposed or no longer are functional. We could grab larger debris. We could grab the enemy, an enemy satellite, and we could grab that and take care of it. So this is and it uses the ionic propulsion, and this is used to grab meteors. If you want to do meteor harvesting, this is how you go about it. Now, they have plans to do this already. As you notice, I did bring an entire this NASA chart that shows how we're doing the asteroid capturing and such. All these are in this is all the NASA missions right behind me. Up until 2030 something. So this is having it go to the Orion capsule. So I say we bring it back to the hub. we grind it down, centrifuge it, separate the elements, repurpose them for our usage, whether we repair, make new advancements on the hub itself, or new satellites that we just invent and put them out there in space without ever launching them, so nobody knows that they're even out there because they never got launched. You actually build them at the hub, and nobody will know the difference because we made them, and they're up there without being launched. That's the ultimate way of doing defense. So, ta-da. Okay, this is Europe's way of doing it the same way. A tow truck or a tug or a capturing vehicle. This again is an overview of different space tugs that are out there. About 5 or so years ago, I did a proposal for a tug vehicle for NASA. They need them. There's reasons for them. So Boeing, I know Robert Friend at Boeing was looking at it, and a bunch of other I call it the big four, which is of course Boeing. Now it's Raytheon. No, it's Raytheon Tech. They're number 2. Then it'd be Lockheed Northrop. So that's the big four. They've all looked at it. Now, this is why it's important is this ISS is uninhabitable at 2024. All of us that know this product know that it's no longer usable. We could actually tow it into a higher orbit and get longer use out of it. The only problem that's still contentious is, okay, well, all the people that built these and all the countries that built these, their purpose of life was not to last much longer. So do we do it and it bypasses the warranty, and do we threaten different areas? Of course, you have to look at the critical features, and that would be where each area is joined up and how things are manufactured and what type of use and where would have to be done. So we could tow it up and work longer. Right now, it's supposed to burn up in the atmosphere in 2028. That would be one heck of a burn up. So towing it would be more economical. Oh, and they, if I can go back one, I got to show you this one. The Gateway Moon to Mars. Let's go there. Okay. Over in the lower right-hand side, NASA's Gateway concept is for the Moon to Mars next step, how to get there. Lockheed's working on it. You see a lot of other groups up there that are working on it. Bigelow's working on it. So personally, I think the Gateway Foundation is superior to all theirs, but you know, they're already on a path. Sometimes you can't change the destiny from that point on. So I'm sure probably Gateway Foundation was probably based on this. So it should be a rotational space station. Now, the economy of it, $738 billion. If you look at all the world compared to us, you know, them combined, we're still the biggest on the planet. Us personally, for R&D, for us engineers and developers, we, in US, it's $247 billion for development or engineering of new systems. And this is the definition for California C4, ground systems, missile defense, so on. You can read it yourself. That's where the money is. And you can see it's growing even larger as we go out to 2024. Cruising along, let's put it to a summary. It actually it employs 2.5 million people, okay, 2% of the entire employment base, and 20% of the manufacturing workforce in the US. The defense industry itself, like exports like F-35, 738 billion a year, 247, like I just showed you, for engineering development. That's us getting jobs. Space industry for communication, rocket launches of different buoys, space buoys. That's around 35 billion a year. NASA has a budget of 22.6 billion, and they were supposed to have like 24 billion, but with the COVID, I'm sure everything's going to be, you know, put back into perspective. Of course, I'm going again back to energy is the world's largest thing in the world economy. Those who have it can control the world. Space economy, mining, meteors and asteroids like you see in the NASA Glenn video. There it is. You can go look at this later. I'm not going to go into detail. I'm going to try to blast through this. Now it's, I've been talking for 1 hour. I'm going to try to zoom this up. The 24 or 22.6 billion for NASA's engineering spacecraft, mainly exploration. But after 2024, or right around 2024, the Space Force will be a DoD separated budget. There'll be areas in there that are classified so that you don't get to see what they're doing for. And a lot of that will be done that way. Space exploration, what was talked about with the Mars rover and so on, that's shown in the bottom. I know it's child looking, but it's a great overview. So it's just interesting. Orbits, I had to throw this in there because a lot of people don't know the definition of every single orbit. LEO is our most populated debris field in the world. When we looked at the Mars Advanced Communication Relay System, we would actually have 5 different satellites, some in LEO, MEO, and GEO, and on the dark side of the moon. So, and that's to communicate with Mars, because right now it takes 12.5 minutes each way for each communication. So anytime they want to make a movement at Mars, it takes 25 minutes per movement, okay? From our command center on Earth to the rover itself, 25 minutes. So we need to improve that, and I've already explained the Mars relay system is, it involves this and beyond these orbits, okay? So now let's look at the rockets to deliver stuff up there. This is going into the future because SLS Block 1 is not flying yet, and neither is Block 2. So I worked on the SLS. It sees 81 Gs plus, so it'd be 162 Gs in all 3 directions at once. Now, if you're at the bottom area where the rocket's motors are, that's the G loading of it. So engineers out there, when we talk about rockets themselves are really super boring and easy. They're nothing but a pressurized beer can with separation chambers for the different fuels. They're very boring and simple. They're not like an airplane. They're really simple. It's the propulsion area that becomes defined and important, and it's handling the 162 Gs in 3 directions. That's the important thing. And then you have Elon's BFR on the very right-hand side, which Godspeed, and thank goodness he chose America to do all his work in. Ion propulsion, now enabled to do maneuverability out in space. The ion drive is key to it, okay? And these are things from NASA. You can see this chart explains itself. This is the ionic propulsion, and this is it being tested at the EP2 Aerospace Corps. They were actually doing some of this testing, and there it is on the stand, a NASA paid for product. And this explains the technology. If you want to maneuver in outer space without carrying a bunch of rocket fuel, burn off, disposable debris, you need an electromagnetic propulsion. This is an ion or a Xeon propulsion for deep space. This is the only way to start maneuvering when you're in outer space. So I want you to watch this video so you can understand its technology. So being that it is an EM drive, electromagnetic drive, an ionized xenon drive, Boeing, Robert Friend, knows that Boeing has one of the best EM drives out there right now. Also Aerospace Corp and others, but this explains the technology, of course, invented at NASA Glenn. Or paid for by people that conceive it. So now if you want to maneuver when you're out there onto a satellite or a maneuvering vehicle for a real Space Force, this is a key propulsion technology that has to be utilized, because you can't carry a bunch of fuel with you. It just doesn't work. Okay. Now, in conclusion, beat our enemies at dominating the world. I don't want to speak Russian and Chinese. And I don't want to have a dictator say that I said something wrong and then my whole family disappears in a field. Create and dominate wireless power, like space-based solar power, and communications, and make space transportation to get from here to there economical, commonplace. The transportation has to be commonplace, safe, and maneuverable. Once you're out there, you got to be able to maneuver while you're out there. And it should be a commonplace. Still needs to work. Has to have a continuous space presence. That's where the hubs come into play. Out of everything I've seen, I still favor the Gateway Foundation. And I do like Bigelow's pods. So, that needs a formal trade study. Of course, that'll be done. And then create space as a manufacturing and a construction industry out there. So that's what it takes. Now, I love these as quotes to finish up. Whatever is good and right is never impossible. My favorite, Henry Ford. And I like what Bill Gates said. I'm an impatient optimist. The world is getting better, but it's not getting done fast enough. It's not getting better for everyone, right? We're all in the same storm, but we're not all on the same ship, right? So anyway. And then I love what John Bigelow said, will America lead or follow? And then when something essential becomes affordable, then its creation becomes inevitable. I love that. My buddy, I loved Lee Iacocca, lead, follow, or get the hell out of the way. Also, his use unconventional thinking and had the guts to carry it out. So, favorite quotes to live by. If you were part of the 777 team or you were at TRW, which is now Northrop Redondo Beach Space Park, they created this, but everyone at Boeing, when they came in, they got this. And it tells you the quotes, like Babe Ruth made a big mistake when he gave up pitching, and then everything that could be invented has been inventing. And this is the guy that's the director of the U.S. Patent Office. I mean, these quotes are really funny and great, right? So, and obviously we know them to be false. Like there is no future in believing something can't be done. The future is in making it happen. And since I'm probably not taking many questions, but I'll try. I love our president, and I love how he can call it as it is because he's got business sense. So this was one of the most comical cartoons. Any more questions? Where he smoked all the fake news. So anyway, and that concludes my presentation. Any questions for anyone? Because I'm done.
Shawn, there are 7 questions in the Q&A.
And how do I see that?
On your Zoom panel, there's a toolbar, there's a Q&A. You click that, it should show up the questions. Or I can enable the person, they can ask the question verbally. How about that?
Yeah, please, because I can't see them.
Okay,
all I have is the AIAA overview.
Okay, I'm going to enable the person who asked the question. Santosh, can you speak out? Santosh?
What's it say? Can you read it? Do you understand it?
I can, okay. Yeah, it's kind of long, so I think it's better that.
Oh. All right, I'm here. I'm alive.
Okay. Yeah, you type long questions. So.
Let me turn off the one of them. Hold on 1 second. Give me 1 second.
Yeah, we got some feedback there.
Yeah, I know, because I had a redundant phone in case my heavy booter on me. Anyway, great presentation, by the way. I got a couple questions here. Watch one question and a couple questions and a feedback. Question is, will the other military services, such as namely the Navy, the Marine Corps, and the Coast Guard, for example, be able to maintain their own astronauts, such as naval astronauts in particular, because each service brings their own culture and unique qualities to the table? That's one of the positive things of having separate branches contributing to, like NASA is right now. That's why I was more in favor of Space Command. But now that we have a U.S. Space Force, it is de facto a surrogate of the Department of the Air Force. So it's going to have more Air Force culture there, and it's going to have other sister stuff. And even if not so, which you know, still may be a good idea to have naval astronauts and Army aviator astronauts, will that be still maintained as it is right now, or is that going to go away? And my feedback.
Well, okay, because they are going to go, they're going to be only 200 people at the end of this year, and then they plan on growing to 16,000. The definition of it being a space domain, and if you look at my slide number 7, one of the things it says the Space Force will include both combat support, enable prompt and sustained offensive, defensive space operations, and joint operations in all domains, land, sea, air. So because it says that they will include it. So I'm assuming the future, they might redefine some of the people that do that as astronauts now might just become the new Space Force.
Sure. And then the second part of it is feedback. Some direct feedback I was wondering if you guys were considering is right now, all of the first set of officers from the U.S. Air Force Academy that all committed into the Space Force, they're all non-combatant types, more engineers and operations type folks. So my question is there a plan to actually send Space Force officers through UPT, which is undergraduate pilot training, so they become pilots, so that they can actually become pilot astronauts? And kind of the ulterior motive in that is that, I don't know if you know about Sustain with the Marine Corps, they had a plan to create a quick reaction force with scale composites to deliver a Marine Corps QRF within 2 hours on any hotspot around the globe, as opposed to the 3 days to 2 weeks of a current MU, which is a Marine Expedition. So that will be a possible application of Space Force astronauts that have been trained as pilots first, that will be piloting such space vehicles.
That's correct. And actually, yes, they would be able to do that because right now they're defining all the avenues of what has to be done that way. And there's 5 branches of the Air Force that actually is going to do the Space Force. You have the 3 in Colorado, and we have, of course, El Segundo is one of the largest, and I think it's Pete Air Force Base is another one. So there are different branches, and they will have new areas and new avenues that have to be, of course, Colorado Springs with the Air Force Space Command. So yes, there are avenues that their career paths have to go through because the means to do the future war fighting, this is where our strategic plan, when it gets to the White House and to the DOD, then that gets defined from a system point of view. And from that, then they can define what personnel have to do to get there. And then you can match up the learning path for all the future Air Force and any type of military branch of what it has to do to get to fulfill the future needs that are going to be coming up. And that's why we have that 4-year infancy for the Space Force.
And
So
Shawn, hi, Shawn, this Michael, stop talking. I can speak at least for the Navy because I am a reserve officer in the Navy. Like for those of us who are in sort of like the space cadre, space track that support missions for like NAVWAR and the space and U.S. Space Command and things like that, they are starting to reach out to officers and folks that have backgrounds in that be interested in doing inter-service transfers. And kind of the nice thing is typically when you transfer service, you have to go down a rank before transfer service. But because they're standing up this force, they're basically waiving that requirement. So the answer is yes. They're starting to look for officers in different branches to move over there, but it's kind of like it's a very slow build up for the time being until they're ready to start building up that force to the numbers that you're talking about.
Well said. Thank you, Michael.
A final question is Starlink. Is it really a good idea to do everything RF as opposed to having a mix of RF and offloading a lot of it to fiber lines in order to avoid frequency congestion and all the other negative effects of having everything in the RF spectrum out there?
The answer to that is yes, because as you look at vulnerability plans for any type of combat means, vulnerability and survivability means that you have to have a secondary force and technique to deliver that and maintain support. So there will always be a combination of sciences and technologies that have to be coupled as a plan A, B, and C. So yes. I hope that answered it. Yes, it would be.
Yes, that did. Thank you. That was good. That's good news.
Okay, good. Any others? Wonderful. It's Saturday lunchtime. I thank you guys. You have my link. Feel free to send me any information or questions or anything you think that should be added to the strategic plan as it comes from us industry experts and myself directly to the president, vice president, and the head of the DoD. Okay?
Any way you could send us the links or to Ken so you can repost them, because the YouTube video, we can't really click on the links, so you can have them listed so we can actually tap on them or click on them.
Yeah, actually, I have that link, and it's in a scribed format, and it's at the beginning and at the back of the presentation. I think I put it 3 places. Would you like me to tell you what it is? Okay. Here's if you went to Scribed, which is www.scribed.com/future-space-force-2020-final. All of that is up there now. The one I gave today is a little bit updated from what I show up there, but everything exists, and you can go through the videos. And actually, I noticed in Scribe, you can actually click on that link with control, and you can actually, it'll pull it right up immediately on your computer. So that is the best way to do that.
Shawn.
Yes, sir. Or just go to Scribe and look up Future Space Force, and it'll tell you.
Real quick question. Appreciate the presentation. It was amazing. I'm in the telecommunications industry. I've been in it for almost 18 years. And I'm just curious, in regards to Space Force, what is your opinion, and how are they going to ensure the safety and stability of 5G used for weaponry and for the military?
Okay, that can be defined, and there's certain things you can't talk online, so I can only point to what I've shown in this presentation. And if you looked at the new jamming thing that they just sent up in March, and they celebrated at Pete Air Force Base, that one has where it can go through quite a range of frequencies, and it could jam or it can protect. So
okay.
There are, let's see what slide that is. I'll give you which slide that is. Let's see, because that's important to know. Okay, slide 19 and 20 explains some of that and it's actually the Space Force new satellites, and it explains how it goes from basic phased arrays, and it goes through the 44 gigahertz uplink, but it can do different skipping.
Okay. That's sufficient. I appreciate that.
Yeah,
and
I can't tell you more about it, but if you go
understood
and look it up, you'll have to go from that.
And then a follow-up on that: how much of what percentage of the Space Force is going to be unmanned?
That right now is still to be defined, because
Okay.
right now they don't even have that full definition. Right now, all they have is what Air Force Space Command was, and the new key milestones I showed you. So right now, all of that is brand new and to be defined. So that's why me giving this presentation to you guys helps define it from an industry and professional point of view of guiding the future there. So,
okay. Well, thank you. Really appreciate it. Hope you can continue to do this for us, because it's very enlightening for what's going on. Thank you very much.
Thank you very much. Have a wonderful weekend.
You too.
Are we all good now?
Yes, excellent. Thank you so
Okay.
much.
Everyone have a wonderful weekend. It's been a pleasure to talk with you. Feel free to keep in touch with me. Bye for now.
Thank you, Shawn.
Thank you.
Thank
Bye,
you.
guys.
Bye. Shekhar, are you online? All right, Shekhar is not is offline. So thank you, everyone. So really appreciate we have two fantastic presentation by two wonderful speakers. So we'll keep in touch with Michael and also Shawn for keeping update for the Mars 2020 and the Space Force. Also keep looking up for our AIAA Los Angeles Las Vegas section events. And this event is being recorded, so it will be posted after the event. So look up to the website and our email notice. Thank you, everyone. Have a good weekend. Bye-bye.